Welcome to Second Nature, a collaborative podcast produced by the organizers and host venues for the exhibition Second Nature, Photography in the Age of the Anthropocene. I'm Marshall Price, Chief Curator, and Nancy A. Nasher and David J. Hemaseger, Curator of Modern and Contemporary Art at the Nasher Museum of Art at Duke University, and one of the curators of the exhibition. I'm joined by my co-curator, Jessica May.
Hi, Marshall. I'm Jessica May. I'm the Executive Director of the Kemper Museum of Art in Kansas City, Missouri. Our exhibition presents the first major photographic survey examining the Anthropocene thesis through the lens of global contemporary photography. The Anthropocene is generally defined as a proposed geological epoch in which humanity has had an impact on the global climate. Over the course of this project, however, we've come to understand the Anthropocene not as one singular narrative, but a diverse and complex web of relationships between and among humanity, industry, and ecology, the depths of which are continually being discovered.
In this episode, we speak with Noémie Goudal and Dan Richter. Noémie is an artist based in Paris, France, who builds and documents elaborate constructions to showcase illusion by photography or film, and the organic as, quote-unquote, invaded by the human-made. Goudal aims to understand landscape by approaching it from multiple directions, blending traditional photographic technique with physical manipulation of the environment. She is interested in exploring forensic histories of geological time, also known as deep time, allowing the land to explain itself through its own history rather than through the history of humanity. In Second Nature, Noémie is represented by Les Mécaniques, one part of a three-part series of landscape photographs that really distort our understanding and complicate visually how we see the landscape. Most recently, Noémie was a finalist for the Prix du Champ in Paris. Dan Richter is professor of soils at the Nicholas School of the Environment at Duke University and former director of the Calhoun Critical Zone Observatory in South Carolina, where he and about 100 other scientists and collaborators study the Earth's critical zone from treetop to bedrock, meaning the physics, chemistry, biology, and human interactions with the atmosphere to aquifer land system. Dan is co-author of the Cambridge University Press book Understanding Soil Change with Danielle Markowitz, and is director of an international network of long-term soil experiments. As a philosophy major when an undergraduate, Dan is fascinated by the history of scholarly disciplines and how interdisciplinarity in the 21st century may transform the Academy of Science itself. He is a member of the Anthropocene Working Group of the International Commission on Stratigraphy, which has proposed that the contemporary geological epoch be named the Anthropocene. Dan and Noémie, it's great to be here with you. I brought you together here because of your shared interest in time and, in a sense, how both of you are timekeepers in a way. And before we talk in depth about time, I'd like to ask each of you to speak broadly about what you do in your respective professions, how you understand this concept of the Anthropocene, and the ways in which your work intersects with the Anthropocene. And maybe, Noémie, we could start with you.
Sure. I think it's in my work, it's a question that resonates with a lot of my series and installation. But for example, in the last works that I realized for the Prix Marcel Duchamp at the Pompidou Center in Paris, it's a video called Suprastrata. I was really interested in a group of scientists and geologists that about a year ago gathered and said, when would be the very beginning of Anthropocene in geology? Like, if there is a date, when would that be? And it's obviously an interesting question because there are so many ways to take it. And from outside, it could be, for example, when the agriculture started, or when during the industrial era, or perhaps even later. So they, all those questions went into, the discussions, and then they decided it was 1945 as a sort of date when, after the nuclear test, when the results or the vestige of the human transformations was not only in pockets around the globe, but was really sort of everywhere. So they actually found some well, I'm not the scientist there, so probably I'll leave you to explain that. But I thought it was amazing to actually think of this very thin layer that is absolutely everywhere around the globe, and that represents somehow visually, for me as a visual artist, represents the human traces of interactions. And in my work, Superstrata, what I've done here is I was particularly interested in the stratus of plastic, which is very much obviously a transformation. It came from fossil energies and then it kind of got transformed. And then it's kind of, when you look at the plastic layers, plastic agglomerates, we can call it perhaps that way, on some areas in the landscape where it's really like a thin, it almost looks like, or it is a geological layer in a way. It's part of it now. And I was interested in how perhaps the archaeologists of the future could actually see that as one of the stratus within the layer. And so I guess in recently, that's the kind of research that I've been looking at. And in my work, obviously, everything is about the stratus within the photographic and the video image, because obviously at the end a photograph is flat and a video is also flat, but within that you have so many layers that you can sort of unpeel or deconstruct, reconstruct. You can stop the view to go further, you can actually prolong it so it can go deeper in some parts of the image. So I'm interested in all those stratas. And for me, there is a link between that is very strong, or that at least I now, I guess, created in my head, because after all those researchers, there is a link between all the geological stratus of time and the time within the image, because an image is not, in my work, I don't make images that are made with only one time, but with many times. So for example, I can have a photograph that is taken, that is reused later, and then another photograph, and then another photograph. So those layers, those unpeeling of different times are very much present. So it's about, I guess all of the works, it's about how I can sort of translate those geological experience, because obviously I'm not a scientist, but it's more how I get fed by those researchers, and in order to I digest them and then I create the work.
And I think we should say too that the work that you have in Second Nature, which was recently acquired by the Nasher Museum of Art here at Duke University, could you talk a little bit about that specific series? Because it, what you're saying as far as the layers go relates so strongly to Les Mécaniques. And I wonder if you could just say a few words about that.
Yeah, so Les Mécaniques is a triptych that, so if I can perhaps start to describe it very briefly, it looks like it's a photograph that is taken in the jungle. I've worked with an installation of mirrors. So in a lot of my work, I build things that I then rephotograph or refilm. And in this case, I build a very large structure made of wood. And I placed mirrors on sort of square rectangles of mirrors. I think there were about 90 of them, so quite a large number. And I wanted to create a sort of, because the mirrors are not they could be completely flat, but they are not, because of the construction is so handmade. So the reflection is not completely flat. And I played with that a little bit. So what you can see is almost like a sort of kaleidoscope of the jungle, because you can see what is happening behind and on the side. And it's, a little bit of a sort of a 360 vision. The mirrors allow this a multiplication of, of all the different views around. And it's almost like a performance, this triptych, because what we did is we took out the mirrors one after the other. So in the first image, you have almost all of them. Then on the second image, we took out some. And in the third image, you just have a few left. And what you can see is through the mirrors, so through the ones that are taken off, you can see the nature that is right in front of the camera. So literally what you can see is really a sort of, that's why I talk about kaleidoscope, because it's really a sort of a vision that is sort of almost trying to englobe everything that is behind, at the back, in front of the camera, on the side, etc. And for me, it was also a way to represent this landscape that is in, a constant evolution, because it doesn't have seasons very much. Like it obviously it's doesn't have our season in or 4 seasons, because obviously there are many definitions of seasons, but it stays. It has a sort of monsoon season, but it stays roughly the same landscape over the course of the year. So it kind of keeps on sort of degrading and going up and degrading, and so it's fragmented differently. So that's why I wanted to play with that, with the mirrors. Sometimes I talk about optical adventure, because it tricks, you have the sort of illusion, you don't really know what you're looking at, because when you look at the mirror, you can see that it's not photoshopped. You can see that there is something tangible and something that you can actually, something that is made by hand. You can see sometimes you can see the wood at the back. You can see traces of the fingers sometimes on the mirror. So it's very much, you can see the materiality. And so I guess for me, showing the materiality was really implicating the viewer to be part of the effort that it was to make the work, or part of the adventure, in a way, part of the process of the making. And for me, that's really important, to involve the viewer in that way.
Thank you. Thank you. Yeah, and I think it speaks to the complexity of the ways in which we can understand the landscape and its history as well. That it isn't just one perspective, but many simultaneously.
Mm.
Dan, I wonder if you could talk a little bit about, how you understand this concept of the Anthropocene and the ways in which your work intersects with it in the work that you do.
Can I make a comment about what we just heard?
Yeah, absolutely.
You make me think of Newton, optics, the showing of materiality. That's what a scientist wants to do, kind of bump up against reality and paint it with broad strokes the best we can. Okay, thank you for allowing me a little bit of daydreaming there. That was wonderful, Naim. As timekeepers, both of us are timekeepers. So soils are my discipline, my focus of study. I'm in love with soils. I grope. Many artists probably grope too. But soils exist on Earth in a very special way. They cover nearly 98% of the terrestrial surface. Why are there so few bare rock slopes? From the tropics to the boreal zone, we have diverse, countless soils. And they develop over time. Some of them are very young, a day old, a century old. Others are more than 10 millions of years, which is worth a pause, given that the Earth itself is 4.5 billion years. Why are even the oldest soils so young from the Earth's perspective? Well, that's because of the dynamism of the Earth and the evolution of the Earth that is so hard to grasp within 70 or 80 years, but is so magnificent. And to think that the Anthropocene Working Group is trying to follow stratigraphic rules, which are very much bound to the 19th century, and we faithfully try to follow those rules to find a boundary. But it's a stratigraphic boundary. These are very narrow rules. These are very narrow definitions that the stratigraphers follow. And so the Anthropocene Working Group tried to follow those rules and made a proposal for the mid-20th century. It matters not that it's 1945 or 1950, but the great acceleration that many different scholars have talked about and quantified, it's very much an Earth system science concept. But the mid-20th century was a time where the stratigraphers could most practically, could most easily decide that this was a place we can call the boundary. Noémie mentioned agricultural time, 8,000 years. That was another very interesting period, boundaries, so to speak, that was most interesting to me, but it doesn't happen with nearly the synchronicity that things happened stratigraphically in the mid-20th century. So it was set aside. There were many different independent places where agriculture developed. It's a very fascinating story, but too asynchronous, so to speak, for the stratigraphers. The first definition was one that also Noémie hinted at, and that was the industrial age, where coal started to be utilized for energy in the early 1800s. And in a sense, all that has followed starts in a certain way from those activities. But that concept, too, even though it was proposed by Paul Crutzen, a Nobel Prize laureate, and carried a lot of weight, the 1800 Fulton Revolution, so to speak, it just didn't satisfy the stratigraphers' need to follow their rules of synchronicity, as well as the post-World War II boundary, this great acceleration that happened in mid-20th century. My favorite, however, that really makes this whole question, Marshall, a lot more interesting than just a stratigraphic question, a lot more interesting, is one that I mentioned in my essay in Second Nature, and that is the late Pleistocene extinction. When deep in our hominid past, small bands of hunters and gatherers and tribes and so forth were migrating out of Africa and into what must have been just totally exciting adventures. And a most inadvertent thing happened, and that is the megafauna, one by one, hundreds of genuses, countless species, frankly, but hundreds of genuses of mammals, big birds, big predators of all kinds, and big grazers went extinct as these seemingly small impact bands made their way onto Australia and across Asia and across Europe and finally to the Americas. What a story that is, because those impacts, which might seem, well, that's a very interesting archaeological, anthropological story, but those impacts on the way the ecosystems of the Earth function were very fundamental. And that's a part of this story that is, in my mind, a lot more interesting than the stratigraphic question at hand, which is to help the stratigraphers build their Earth time clock, which, frankly, is one of the greatest achievements of Western science, in my mind, is the Earth's history told from a scientific point of view of the rock record. It's a stratigraphic story. So I didn't tell you much about what I do, except where I started with soils. How does soils feature in this? We are eroding soils today in the late starting in the 20th century and into the early 21st century like never before. And that's of great concern, but it also is a part of this great acceleration as well. We're transforming the valley bottoms, our valley bottoms across most of the Earth's surface now is inundated with legacy sediments. So the Earth's strata, which can contain the radionuclides from the bombs of the mid-20th century and Noémie's, sorry to say this, Noémie, but Noémie's plastics are entrained in these legacy sediments that cover nearly every river bottom where people live, in the watersheds that people live. So we are really transforming the Earth in a very accelerated way from the mid-20th century, which is where I started here, Marshall.
And what are the reasons, Dan, for this sort of large-scale erosion? Is it primarily industrial agriculture and its rise, or are there other factors involved?
Yeah, it's industrial agriculture for sure, in erosive and erodible landscapes. But there's all the ways that we build and construct transportation routes and cities and so forth, that the movement of the Earth's surface particles of soil is today largely controlled by human beings. I'm not sure I'd want to measure ourselves. We must measure ourselves against the earthworm at some point. I've never done that calculation, but earthworms move a lot of soil particles too, but they usually move the soil particles within a traditional system of soil. They're part of the great mixing that goes on in a conventional soil. Yeah.
And do you see accelerated or intensified weather patterns exacerbating this situation? I mean, is that part of it as well, part of the equation?
It's certainly potentially so. And for me to look at the climatologists I know who are doing attribution science in their modeling, yes, wholeheartedly. Um, I am an earth scientist that appreciates the great long time sweep, am fully interested and engaged by the cataclysmic things that have happened in the past. So yeah, I'm a little bit cautious about even the wildfires for that matter, as much as human beings are driving them and are involved in them, California in particular. I sometimes I wonder, can we think about ourselves the same way we did prior to California? I'm sorry, that's such an Americanist point of view, but the image of what's happened in the last couple of weeks is just altogether startling and breathtaking. I wonder if we can even look at climate change in the same way, given just the breadth of the Earth's systems that are changing rapidly in front of us. Yeah, climate is definitely part of it. Absolutely.
And I ask you a question about the dryness of the soil and the water that is below, like the groundwater. I just wanted to ask you if there was a link between when, like, I don't know the details of the Californian fire, but in France we have Les Landes, Landes, that is also a very area in the south of France with all the pine trees, and we have catastrophic fires every year, and the land is so dry. It's not about just the fires outside, but it's about the fires inside as well, because about the dryness. I just wondered how why suddenly a soil can become so dry and that the water doesn't somehow circulate underneath, like how it should flow or how it usually flows. What is the mechanism that creates this dryness?
So I don't know these pine regions that you're talking about, Naomi, but I imagine systems that perhaps have a wet, dry season to them to begin with. They're pretty close to the supply and demand of the water cycle each year. And those are systems that are perched quite tenuously when the supply equals the demand. In other words, when the rainfall or snowfall is approximately the same amount that the trees and the runoff, but particularly the trees and the plants are consuming. So when the evaporation is approximately the same amount of rain as the inputs, the rain or the supply, those are systems that are really perched on that dry knife edge, you could say. And so a few years of dryness or decades of dryness count a lot. And the trees, geologically speaking, have responded. You make me go to the Sahel, where across a vast region, there are these same kind of climates that are poised on this evaporation rainfall teeter-totter, you could say. And for most of the Sahel, of course, they're over on the dry side. And yet vegetations respond to that, but they respond to them in such extreme ways. These are extreme circumstances when the land is exhausted of its water storage capacity, which of course is a very very important part of what soil does, is to retain water when it's available against the forces of gravity, we say. Yeah, water retention.
It is terrifying to see. It's terrifying to see these images in the popular press of what's going on in California, and I mean, hopefully one of the good things that will come out of the dissemination of these types of images, which we see on a regular basis these days, is action. But you two sit in this privileged position of having sort of knowledge beyond what we see, in the press about why these things are happening. And I want to shift a little bit and ask you about how you grapple with the sort of ethical and moral implications of what you witness. And of course, does that impact, your work? And if so, in what way? You see these things in statistics, in real life, right? How has that shaped your understanding of your work in the world?
Well, I think in my life as a citizen, so in a way, my reality and what I read in a paper and what is quite, for some reason, I always put a distance between that and my research, where I create a bubble of in my work, in my studio, and all my researchers are about deep, deep time. And that's what I love about those research is that it takes me so far away and it helps me to look at the landscape with such different angles that are a vertigo. It's so vertiginous to see, how a mountain is now completely eroded, or to see a land, piece of jungle that is now, underneath the ice in Antarctica, ended up in a gold mine. Or for me, I think I'm in my work anyway. It's two categories. It's two categories, and obviously, I think for me, it's looking at, especially with the fire, I've made a film called Below the Deep South, where I work first of all with the cone of optics. So I created a set of decor. The camera doesn't move. It's a fixed plan. And in front of the camera, I have a backdrop that is sort of taking the whole frame of the camera. And then another one at the back, and then another one at the back, etc. I have 9 of them, and they become bigger and bigger. So they sort of stay within the cone of optics. So, and I make them burn one after the other. So one burn, and then you can see the second, etc., etc. And for me here, the fire was quite, obviously, it's very violent because the paper backdrops are representing jungles. So when it burns, at first you think that you're really looking at the jungle that is burning. And then you can see after a while that is actually just paper. And then it does it again and again and again. But every time you're kind of tricked and you think, okay, now I'm in the real jungle. Oh no, now I'm in the real jungle. So for me, that what I felt is, I'm talking about in a geological ways, that the fire has a double role. It's a destructor, obviously. It's a huge destructor, but it's also a huge source of energy, and it's a revealer. So in a way, in my work, the fire helps to reveal the backdrop that is at the back. So I wanted to also look at it from both angle and from how it is obviously when at the sort of the beginning of or the birth of humanity, or maybe one way of looking at birth of humanity is the fire was suddenly how do you say, not invented, but
Domesticated.
Domesticated. Then it became obviously a huge shift in in how our lives got more complex, and how, with food and etc. So I think I'm interested in always looking at and referring those events in, very long period of time. And I guess the landscape, now that I've done all those researchers on paleoclimatology, and I guess the landscape is, because we know the Earth landscape, we can travel, we can even Google and see what is going on there. But what is, I guess, a little bit more hidden is its historicity and how it looked like 10,000, 30, or 300 million years ago, and etc., etc. And I guess that's in my geographical zone, is through history more than really, I guess, geopolitically what is happening now. I guess it's obviously very important to me as a citizen. It's in my concerns, but in the work, it's actually quite far away.
That's a great question, Marshall, for the two of us. I remember the day where soils got my attention as a graduate student. It was quite amazing. And I knew that the professor was on his knees scraping the foliage of a forest away from the mineral soil below, and he just started talking narratively about how much history was in the soil. This was in Mississippi. He invoked the enslaved people and their songs and their singing, and that the fact of the matter was that all that was alive still in the soil. And he says, nobody studies the soil, so few people. And I just thought, wow, that's a really, there's a place for a home. And at that time, it was all about how to connect my interest in the soil to contemporary events, because I've typically been involved in environmental science programs. I think as my career has gone on, when I look at the things I'm interested in now, I definitely try to connect the dots. So one of the issues that has taken over about half of my laboratory has been locating historic soils that are contaminated in cities. And it's a topic that hardly anybody has thought about, worked in, and so forth. So it's a vast frontier that's open to us. I exaggerate. I have many colleagues who have dedicated their lives to studying this, but the number of backyards and numbers of cities is almost unlimited. And there's so much good work that can be done with contemporary instruments that revolutionize the way we can do our science in cities. In any event, that's connecting the dots to environmental health and people's backyards and neighborhoods that are rich and poor and so forth. And I'm not saying that I'm a Superman or anything like that, but it's just an approach. And I got to think about the fires the other day because my dissertation in the 1980s was all about prescribed fire, which is a way that so ironically, it's such an important approach to fighting wildfires. We fight fire with fire. Well, fires have been a part of not only the wet, dry ecosystems, but many of the humid ecosystems throughout geologic history. And human beings have basically taken fire out of the landscape. And so prescribed fire is a way that step by step we slowly reintroduce it and take advantage of those populations, those communities who know much more about fire than many foresters do. And basically, it's a challenge to bring fire back to the land carefully as one of the approaches that we have to adopt to cope with the potential for wildfires. And I want to say my wife, my greatest fan, she makes this observation. Why aren't you studying fire, Dan? You teach about fire all your life and you don't study it. Well, now I'm kind of moving toward working in fire again. And it's such an opportunity. You used the word privilege. It's such a privilege to be able to do this kind of thing at such an exciting time. I would ask Noémie, though, for as much as she wants to characterize her work as being about the deep past, what happened in the deep past, I know you know this, Noémie, is so much a part of the contemporary scene and the way the incredible Earth is functioning. So it's really important to do these paleo investigations to more fully appreciate what is in front of us.
Yeah, exactly. And I think that's another dimension. When you look at a mountain or a river, and you have the full history of what it used to, or what it's. For example, a mountain is probably the most obvious example of what the force. It's quite violent. The mountain, the
Oh,
force that
yes,
that must have
yes.
been in order to create that peak. Um, and I guess it's looking at it through a movement. It's not a fixed entity. We're not on a fixed entity. We live in a planet that is in the constant flux. And studying this flux, I guess, helps me to look at it through a very different angle. And I guess it also helps to reconfigure or also our place, on this planet. Like we are
Oh,
on our human scale time. It seems very fixed, but we are still part of this movement, this
mm,
very, very long movement. And it's very, very vast, quite large, to think that, probably be too large and too, I talk about vertigo, but I think that's really how I feel sometimes. It's just too, but at the same time, for some reason, for me, it also helps to give a sense that it's quite reassuring that it has its own pace as well, that it's still, in an evolution that is,
yeah.
and how the human activity is sort of making it move in parallel to its own movement, its own very slow movement, and how the human activity is it's like two wheels that are, suddenly the wheel of the human activity that makes it change, the sea level, everything will slowly sort of change. And then the earth itself has its own rhythm. So when that connects, I'm interested in that, when that connects, what happens and what will happen in the future. I think that's by looking, as you said, by looking at the past, that we also understand models of what could happen in the future. And I guess looking at on smaller scale of time, but also looking at, for example, in 100 million years, they talk about the continents being one again, as sort of again a monocontinent, Pangea, and and so yeah, I guess that's, for me, that's that's the connection.
So that puzzle that you mentioned as kind of the two pedals on a bicycle or something is what I imagined. But you can see how some scientists could put this and do put that together into a mathematical model. Um, and I'm happy with that. But it is a hypothesis, and some of these Earth models that integrate human action are just incredible in their achievement, but they are, in an important way, a hypothesis. And so I've kind of gravitated in the other way. Perhaps I see my strengths as not being so quantitative as a lot of my colleagues, and I very much like observations. So I've been drawn since that same day that I realized the soil was something special and that I could make a home there. I've been drawn since those times throughout my whole life, in fact, in terms of looking at a farm or a place and sampling it over time, periodically. And so I have a 70-year-old project that's a soil field study that I inherited from scientists that established it. But it is now has data from it that is basically matched by maybe 100 other places on Earth where soils have been studied over time. Some of the oldest ones are in Europe, not surprisingly, and they date from the 1840s, where wheat fields, for example, and their soil have been measured through time. These reveal so many surprises. And let's see here, where am I connecting to? How did you put me onto this train of thinking? Well, it was how do we really bring together, how do we really fully understand what is in front of us all over the place, where the human is mixing with these natural forces? And when one can do it by modeling, of course, but one is really important for us to observe how it's changing too. Um, and so that's kind of my angle on it, so to speak, is to support the 100 or 200 long-term soil ecosystems studies that are out there that no doubt will be able to help us project another 100 years. So in any event, yeah, many surprises. The story is not fully told by any means.
Yeah, and I think that's important to highlight, Dan, how your work has tangible effects in the real world, and maybe most recently, and on a local level too, the study that you were part of looking at some of the soils here in the city of Durham, North Carolina, and the report that came out of that.
Yeah. So this is part of my fascination, my newfound fascination with city soils. We had done a couple of city soil studies in Durham, where Duke and Nasher are located. And one day I noticed on my laboratory wall a historic map of Durham streets from 1937. And my colleagues, who are social scientists and environmental humanities people, have used this same map to help them understand issues of social justice and environmental health. Because it is 1937 Durham, back at a time where the city was segregated. It's a public service map made by the city, and it demarcates the African American neighborhoods from those neighborhoods that are white. It shows where the respective city parks are. It's a gruesome map, and yet it's less than a century old. It's our world. But in the fine print, we noticed there were these little notations for city incinerators. And this is a 1937 map. Very few people are around to say what that is all about. And I noticed that one of those was at the intersection of Club Boulevard and Guest Road, which Marshall probably knows where it is. And I knew it because I've lived here for 40 years as Walltown City Park. And whoa, that just hit our lab like a slap on the face. And we looked through this map a lot more carefully. We found 4 of these city-run neighborhood incinerators because as soil chemists, we know that when you burn city trash, particularly 20th century city trash, the ash elements contain a whole host of contaminant metals, specifically lead. And so we asked the city Park and Recreational Department for permission to sample these 4 parks. We were able to sample 3. I have this incredible instrument. It's an X-ray instrument that in 20 seconds will give you 20 metals. 20 seconds. Oh my gosh, it's revolutionized my work. In any event, we created these maps, and of course, so much trust was lost in terms of what a city park is within Durham. And our paper came out in 2023. That became public in 2023. And now, frankly, what is a scientist to do? So we've circulated that paper. It's got a lot of notoriety. But on the other hand, we know that this story of Durham is not just a Durham story. And we know that we estimate that about half of the cities in the US and Canada have similar stories yet to be told. And so I got a Bass Connections project, which is a Duke University endowment, Naomi, to do a class research project. And I got 10 active students, 4 PhD students, 2 high school students whose motivation is equal to these PhD students. And we've basically been building a data set since September of 200 cities in the 2 countries. And then we'll write up a paper on that as fast as we can. I mean, it doesn't make me feel good each and every day. We're about to create, I think, well, if Durham's story is any example of what might happen in other cities, we are communicating with these cities, but nobody's incentivized to want to find out about these things. And that is because our reclamation, our remediation processes that we have to heal the past, so to speak, are so slow, are so costly that Durham, with its 4 small city parks, actually 5, that are known to be contaminated with incinerator ash from before 1940, 5 parks are contaminated. That's tens of millions of dollars, if not more. There's no incentive to really take apart these places and heal them in a way that doesn't take decades of time. So more and more, our lab is getting interested in interacting with the EPA to think about these kind of problems differently. Yeah.
Well, and it's a bit of a catch-22, I would imagine, because there's social cost for the remediation as well. So the community underwent the initial trauma, or the soil underwent the initial trauma, and then the remediation itself is a kind of social trauma for the community, or it can be. It's a complicated question, but fascinating, and I think reflective of how these issues resonate on a very local level, right? And literally in our backyard.
Yeah. Which
I,
makes it exciting and makes it possible for me to use my privilege to do a sabbatical with the remediation people in Raleigh. And so that's what I'm doing this fall, and really learn about what it takes to reform the contemporary remediation system that we have.
Well, we've alluded to this throughout the conversation, and I would like to maybe conclude by raising this point and diving a little bit more deeply into it. A couple years ago, I read Martin Rudek's book, Earth's Deep History: How It Was Discovered and Why It Matters. And one of the things that struck me was how relatively recently we've understood the Earth as being 4.5 billion years old, only for the last couple hundred years. And I've also just read, as maybe you have too, about this ice core sample that was taken that's nearly 2 miles long, extracted from Antarctica, representing an atmospheric record of about 1 million years. The oldest sample yet, as far as I understand it. Um, it just blows my mind to think about this. And Dan, I know you're not an atmospheric chemist, but I wonder, for both of you, why is it important to look increasingly further back in time, and what can it tell us about charting a path forward in the Anthropocene?
Well, I think for me as a visual artist, just the idea that and actually I came to study paleoclimatology after I saw a film of Claude Lorius, who is a scientist who went to it was a documentary on his work. He went to Antarctica and started those diggings, but years ago, when it was in very, very difficult conditions, and they started with one single small carat of ice, and then they dig deeper, deeper, deeper. And then I went to Carotech. Don't know if you say that in English, or Carotech, a library of carrots of ice, and you can literally see you can see them, and you can see the lines of time. And I think it's a lesson of humility that is so strong that I guess looking at how, through all those years, those very, very long period of time, what we represent the amount of lines that we represent is so small that just having that in front of your eyes, it's a very strong experience that brings you down to something, a lesson of humility. That's how I really felt, and that's what it was important to me.
Yeah, there have been more than one philosopher, scientist to make the comment that the idea of deep time is an idea that's among our most fundamental, perhaps. I need to give you a book about Claire Patterson, who was a Caltech scientist who it was in the early 1950s, dated the Earth at 4.5 billion years. So it's not even a century since we've known the scope, and his estimate was made with lead. And in the course of doing his scientific studies, by dating the Earth through lead isotopes, he was in Southern California, and he basically discovered how contemporary civilization, with its leaded gasoline and leaded paint and leaded ceramics, was poisoning himself. He couldn't get a lead-free laboratory without going to extreme measures in any event. So the ties amongst all of us through this deep time has a lot of potential to even be used in education in new and more ways. If I'm to understand your question or your comment, Marshall, why does the past matter? So when I listen to conversations around campus, around the climate, for example, I'm led as a geologist to really being impressed with how there are perhaps 50 what we call critical minerals that are going to be instrumental, that are already instrumental in how we live, but are going to be very instrumental in this energy transition that we all seem to want to try to move along. As an environmental scientist, however, mining of 50 new metals brings on a lot of imagery and a lot of appreciation for how difficult that'll be to pull off in an environmentally sustainable manner. But understanding how the Earth works, we know that many of these critical minerals leave behind signatures of themselves, these critical elements, in the soil. So I've got another project where we're trying to use soil lithium, for example, understand why it leaves behind a signature in the surface soil, so that hypothetically exploratory geologists, you scrape up the top couple of inches of soil rather than bringing out a drill rig and coring into the earth tens or hundreds of meters, compromising groundwater systems and so forth. There's all sorts of things that we can do. And that's why I want to somehow or another get into this discussion that the story is not fully told yet. We can't begin to understand what the future is, except that it's pressing fast and pressing with such force, to use that word once again.
I think the fossil energies are quite a good example as well of how long it took to create this very strong energy, such as coal or gas, and then how fast we actually can use it and burn it. And the relationship between the long time of creation and the time of use is completely unbelievable. It's
Yes.
on the time scale.
Well, and Noémie, that relates to what you were talking about, that imagery of asynchronous wheels, one moving faster than the other. It's a good metaphor for that.
Exactly. Yeah.
Well, I want to thank you both for participating in this. We could have a much longer discussion about this, to be sure, but this is only part of the picture, and I appreciate you sitting down and speaking today.
Well, thank you so much.
Thank you, Marshall.